Mick and Christian and I have the opportunity to walk you through basically where we are, why you should care, and where we think we're going to go here. So with that, I'll turn it over to Mick to provide everybody a grounding of the OHDSI vocabularies.
Thank you, Patrick. So after Melanie last week has introduced us to the use of vocabularies, we thought we can give you a small peek view into the OHDSI vocabulary engine room. Next slide, please. I'd like to start with introducing those questions again that we had when the vocabularies have been made. So it's about standards, and I like those two quotes about standards, that you have so many to choose from, and that everybody wants one, but nobody wants to use anybody else's. So this is the situation we're in, and with a myriad of standard terminologies that exist, something had to be built so that we can actually use them for analysis. So many of them have overlaps. They started from a defined use case, have grown since. Now we see the overlaps. And we know that in a common data model, we should ideally have one standard concept for a clinical attribute. And that's what we're aiming for. So the common data model and the vocabularies are therefore inseparable. They need each other. In order to do that, backbone terminologies have been identified and chosen, and then many other terminologies have been introduced into the sum of standardized vocabularies, so that we can build relationship entries to those standard concepts that we define. Next slide, please. What is the purpose of the standardized vocabularies? Just to line this out. So one standard concept for a clinical definition, providing relationships from non-standard to standard, such as in source to target, that can support the ETL step. But also, and Patrick will go into more detail later on about this, support analytical use cases. And we can do so by providing additional information such as hierarchies. Next slide. Patrick has made this nice visualization, giving us an idea about what is the vocabulary made of. So we see lots of drugs, some standard, lots of non-standard. Then the other usual suspects like measurements, observation, procedures, condition, lots of devices, although they play a lesser role at the moment. So all of this will give us 134 vocabularies, 40 different domains. We have just passed, and we didn't notice, the 10 million concept line. So shoot. Okay, next chance is then probably 100 million, hopefully not. And out of these are 3.5 million standard concepts, and then lots of others, a huge amount of relationships and ancestor relations. All of this, one shared resource. Next slide. This visualization points out those what I call the backbone terminologies. The light green is the amount of standard concepts. So we see those clusters with SNOMED, LOINC, RxNorm, and a couple others, and see all the relationships pointing towards those. See a couple of those which are homegrown, such as the OMOP extension and the cancer modifiers, which now are our own OMOP OHDSI vocabularies, stuff that we indeed did not find in the world and had to build in order to fulfill the requirements that we have. Okay, next slide, please. Okay, so what are those vocabularies? We have about 90 vocabularies which are in active maintenance. 10 we adopt from UMLS, including their mappings, so that's a fairly easy step. We have OMOP metadata that actually are needed to make the OMOP CDM work. We have some internal creations like the ones I mentioned before, RxNorm extension, OMOP extension, cancer modifiers. And the remaining ones are from various sources, many of those the so-called source vocabularies. Next, just a click. Then we have 21 which are somewhat outdated, and inactive and deprecated ones. So the 91s are the ones which we're actually currently looking at and working with. Next slide. Who is doing all of this stuff? I'd like to introduce you to the team. Now, these are the Odysseus people currently working with the vocabularies. One person I like to start with is Timur. He is our database admin for the vocabulary server and a SQL wizard who is doing a lot of steps. Right? Oh, you. So, who's doing a lot of steps in the processing of the vocabularies. Then this is kind of in seniority. Oleg is also with Odyssey quite a while now, and is doing mostly SNOMED, Loing, and has been doing the UKB conversion. Vlad is our oncology expert, so he's part of the oncology workgroup too. He's been doing the NASA, the CAP, and most importantly, the cancer modifiers vocabularies. Barbara has been taking over the genomics from Denise. We'll get to him later. And now the second row is Mikita, who has been looking at the Medra vocabulary latest. Mikhail, or Mike, who is now teaming up with Vlad for the oncology work. Irina has now is owning now the ICD family of vocabularies. And Maria is looking after Loink and OMOP extensions. And now I would like to introduce two new additions. One click, please. We have Masha and Dimitri, who have just joined Odysseus and are currently in training right now. Now, next slide. We'll take a view back into the past. Christian, of course, he is the godfather. Thank you, Christian, indeed. He's the godfather of the vocabularies. And in the beginning with Anna and Dimitri, has been doing lots of the work. So we see our Ukrainian contributors here, Dimitri, Polina, Eduard, and Denis. There are two more, which I don't have pictures for, like Violetta and Yevgeny. And those have been contributing loads of stuff to the vocabularies. Dimitri being the lead of the team in Ukraine, Polina with her thorough knowledge of Loing and ATC, Edward doing all kinds of SNOMED stuff, Denise owning the genomics, for example. And last but not least, we see Alexander as the current lead of the Belarus team, so the people before, except Timur, are from Belarus, and myself, based in Berlin. All right, next slide. And what it is that this team does is they create obviously new vocabularies. They introduce new vocabularies to the Odyssey vocabulary stack. The vocabularies need to be refreshed. We have maintenance and support. And that means we go through GitHub issues and or forum posts, and sometimes just give advice on the forum and or just fix the bugs that others have found and reported. The team also does documentation around what is being done. Most of it can be found in GitHub at this point. That is technical documentation on the actual process of the vocabulary creation per individual vocabulary, as well as general information around how the vocabularies need to be used. We do think about architecture improvements, for example, how to deal with SNOMED and hierarchies. Try to innovate both on the automation area, trying to automate more steps in the vocabulary creation and maintenance process, as well as innovate, and we're getting to other things later on, to repair sore points like version control in concepts and vocabularies. All right, let's go into a bit more detail now. Oh, sorry, yeah. Other contributors that I would like to mention as well. It's not only the vocabulary team who contributes to the vocabularies. Obviously, it's also other people. So the vaccine work group is working on the vaccine ontology, and in the long run, we want to introduce this as a vocabulary. The Korean community has been providing so many additional vocabularies that we then converted and made available through Athena. Same goes for the Chinese community, and most recently, Jake Gilberg with the Health Equity Work Group is working on the race and ethnicity vocabulary to also be introduced to Athena or at a later time, or to improve the current one. Okay. Next slide. So very quickly, I'd like to outline how we get an OHDSI vocabulary into life. Next slide. We get access to the source data. That's the first step. So we discover the data structure and try to figure out what the semantics are. Oh, I forgot to mention, all the people in the team are actually medical doctors. One is a medical student. So the entire team has very thorough medical background, which is necessary to do this stuff. We then import the data, the information into our development database, and go through a couple of steps to actually make this data accessible. Then we can develop scripts to perform structure conversion and automate some mapping. Let's look at this in a picture. Next slide. So one click. From the initial discovery, we find that there is quite a bit of data in it, maybe in different domains. We, in a first step, sort the stuff and bring it into a source structure so we can work with it. And after that, we would go through, and that's obviously the most complex step, would go through a process where we try to put them in the right place and create the respective mappings, so that in the end we have either non-standard to standard mappings, or if it actually makes sense, have the respective concept as a standard concept. If there is no other concept representing this information, then it would become standard. There are that's an iterative process, so we go through this a couple of times. Sometimes we also take it to external tools like Usagi to supplement the efforts. In many cases, the results need to be curated manually. They end up in these orange blocks, which we call the stage tables, and from there on, they can go through a QA process until they actually leave the development server to Athena. Next slide. There is an alternative to this. Not everything has to happen on our premises, but the heavy lifting can be done by other people and has been done by other people before, like the Koreans, Chinese, and so on. And we could then have all the content transferred to us in that stage table format, which is not very complex, so that it can be processed by us in the development server again, go through a QA. If something's wrong, we return it, and it has to be repaired. And then the whole machinery can still run so that we can release to Athena. And that's something that we want to pick up in the future more often. Next slide. Okay, that's what's happening if we actually do the QA. We have some automated stage table inspection. So we look into the stage tables and have plausibility checks. Very often we find stuff, then this is manually reviewed. And once we are pretty confident that the data is fine, we prepare target tables. Then an important step is being done. That's called the generic update, and you would be able to find these in GitHub. And the content is now transferred from stage to actual basic tables. That's the step when we create the unique concept ID. And that's happening in the development server. Within the generic update, which is a huge process, we ultimately also fix dependencies and relationships, and then everything is ready for release, can be released to Athena at the same time we provide a report and analysis about it. That's what also ends up in the release notes. Okay. Next slide. Let's summarize again. So production steps are source data conversion. Then we put the stuff in stage tables. We fix anything that's not working. We go over to generic update. We double check if everything is fine, and then the actual concepts end up in Athena. That's the process. Okay. This is a quick example what we would normally look at. So this is an example for a condition type vocabulary. Very often they have a hierarchy. We want to preserve that. Very often it's a non-English vocabulary, so we have to translate the terms so we can map them. Then we do the actual mapping, and that's a multi-step process normally. And for conditions, it ends up mostly to be a SNOMED target. But this very often cannot be done automatically or automated, but will require a lot of manual curation. For example, conditions are very often complex, so they might require multiple mappings. Then again, stage table content, QA scripts, and adjusting. And for drug types, next slide, it's slightly different. So there is the so-called Rx norm extension. Whenever it's a non-US drug, we would need to go through a special process. Anna has built and documented this process. So in drug types, we need to look at multiple areas. We need to figure out what's a product, what's a clinical drug, what are dose forms and ingredients. So it's very complex. We then put all the data in predefined stage tables again. Would have to work on everything that is left over, and again have a different set of QA scripts that go over these. Then the boiler is started. So it would create an Rx norm mapping if possible, or create new Rx norm extension entries for concepts that cannot be mapped to Rx norm. So again, lots of manual intervention required here. Okay. Next slide, please. And how do we keep them alive? Next slide. Well, we have a refresh cycle. For some of those, like the backbones, we have a pretty frequent, or at least a very clear refresh cycle. For SNOMED, we now try to combine all the three sources, UK, US, and international, into one. That sometimes means we only have one SNOMED refresh per year, but we'll discuss that and see if we might actually want to do this differently. For others, like ICDs or any other, we pull in the sources automatically for stable sources. So if you have a stable URL, we can pull from, we process that. And then once it's time to actually refresh the vocabulary in Athena, we manually pull those sources into the development server and subsequently process them. After that, again, extensive review for all the refreshes. Questionnaires, all of us is a special case. This is something that for the PPI vocabulary is worked on demand, basically. Next slide, please. Then fixes and additions. What do we do here? Melanie has shown you last time already. You go to the help page in Athena, you get this pop-up, and it tells you not only the version, but it also gives you a link to report vocabulary content issues. And then you end up in the vocabulary GitHub issues. And whenever you find an actual issue in your vocabularies, please let us know, and we'll try to fix it as soon as it's possible and working with our schedule. Sometimes we just add urgently needed concepts as it was necessary during the COVID pandemic. And then they end up in the Odyssey vocabularies and maybe additional information as well. Next slide. Where can I find more information? Again, in the GitHub and in the wiki. So we have a list of the standardized vocabularies, which is currently being still built. It has quite a bit of white spots still. But this should give you more information. And if you're missing something, please also do not hesitate to create a GitHub issue and say, can you please provide the information for that particular vocabulary ASAP, because I really need to know. There's also in the wiki a vocabulary roadmap, which we update quarterly. And this gives you an approximate idea what we are working on, what we're planning for the rest of the year. And you can just, like, if you're interested in a particular area, a particular vocabulary, you can try and look it up and see where we are planning to work on it or refresh it. Okay. What we know where we should do a bit more is a couple of areas that I've listed here. So the version control is something that we're discussing a lot and trying to find a good solution how this can be applied. Releases need a bit more information around the release, and we hopefully maybe can limit it to a couple of releases, to not have too many. So the process needs still some tweaking, although it's pretty okay right now, but the documentation needs to be better. And we need to work on more on the general documentation, thinking about introducing a dashboard, which would probably replace the wiki in some areas, and also extend it by best practices around vocabularies. All right, that would be my part.
Great, thank you, Mick. And I just want to, I'll say on behalf of the community, you know, I think almost 200 people on this call. Pretty much everybody here is here for some reason because they're probably trying to use the OMOP Common Data Model. Probably most of them have downloaded a version of the vocabulary, and probably none of them have actually had a full appreciation of that this vocabulary doesn't just like magically show up and update itself, but it's a huge amount of effort by a lot of talented individuals that we don't always necessarily get to take the time out to recognize. But I want to thank all of them individually for their hard work, and thank you, Mick, for your leadership and continuing to drive this forward on behalf of the community. So with that thank you out of the way, I want to I have a bone to pick about the vocabulary, at least in the way that some people talk about it. Because you heard last week from Claire's workshop, and Melanie gave a great presentation about the vocabulary, but it seems like most of you think that the vocabulary is just a tool to help ETL. And actually, Christian and I have many fun debates about it, because I don't actually think about the vocabulary as an ETL tool at all. I actually think about it as an analytic engine that helps me achieve my part of the contribution to Odyssey's mission, which is all centered on actually trying to generate reliable evidence. And I actually would assert very strongly that we can't generate reliable evidence without a reliable vocabulary underpinning it. So what I want to do here in just about 10 minutes is give you a whirlwind tour about ways in which I think about using the vocabulary to solve analytic problems, not just standardized data. Mick highlighted all of the content that is contained within the vocabulary, and he highlighted particularly that there are concepts that are standards and there are concepts that are non-standards. And many of you probably, your first entree into the vocabulary was, how do I take my data that's in these non-standard codes and map it to the standards, map it to the standard concepts? That's totally a fair and good and legitimate use case. But what actually gets me excited about the vocabulary is, once data is mapped, what can I learn from this standard space? Or more specifically, in many of our cases, we have classification systems, and how can I actually make use of these relationships between concepts to actually draw meaningful inferences? And so Mick showed our picture of the network graph, and he highlighted that it's complex to create these mappings. And indeed, our team does a heroic effort to actually put these mappings together. But what gets me excited when I see this like hairball of a picture of all these vocabularies mapped to all of these mapped together is how we can actually learn across different vocabularies and actually gain insights from this existing knowledge graph that we can actually apply into our analyses. So my main point that I'd like, if nothing else for you to take away, is that the Odyssey standardized vocabulary is not just a tool for ETLing to standardize your real-world data, but actually the Odyssey standardized vocabulary is a tool for analysis to generate reliable evidence. And I'm going to show you just, I'm going to give you a quick whirlwind tour through a few very, very simple examples of real things that I've actually had to do even just in the last 2 weeks to answer real questions within my organization and with the work that I do. That is a demonstration of how easy it is to do things that are actually kind of pretty profound and pretty cool. The first thing is many of you might not be aware of this resource, so I want to recommend that you take a look at it. It's at data.odyssey.org/query library. Maybe somebody can pop that link into the chat for those who aren't seeing it there. But this is actually a nice shiny app that our community built. We initially started this back in the, I think, early in the OMOP days. We've expanded it to be Odyssey, and our Eden collaborators have contributed meaningfully to it. But basically, it provides you answers to questions like, if you need to find ingredients that belong to a drug class, how do you write an SQL query to actually answer that question? And we've provided standardized queries for a very large set of different types of questions one could ask of the CDM. And many of those questions are actually just questions you can ask of the vocabulary that provide very, very straightforward little queries for how, thank you, Craig, for how you can actually provide an input, run a query, and get a standardized output that it could actually then be an object that you could actually compute on. And this is a really good resource. There's a lot of really nice example demonstration templates that you should take a look at. But what I'm going to do is just walk you through some of the questions that I actually face on a regular basis and show you how easy it is to write simple queries to answer things that are kind of useful. So here are some analytic questions that a vocabulary can answer, and I'm really just cherry picking a very small number of these. There's many, many, many more. But it is frequently the case that if I'm thinking about drugs, that somebody is talking to me about a drug class. And implicit when they describe a drug class is that they presume you know what are the ingredients that belong to the class. But unless you are a card-carrying pharmacist with an active repository of all that knowledge in your head, when one person says the name of a class, it is not necessarily obvious that you know all ingredients that the complete list of ingredients that belong to a class. The kind of thing that a knowledge graph can actually just provide us explicitly. Another thing we can do with the vocabulary is, given that you actually have a drug, maybe a specific ingredient, you might be interested in what are the indications for that ingredient. While it seems like it should be self-evident that, well, if there's a product, it has some approval, there's probably a product label that lists that information, it's actually pretty remarkably hard to actually figure out the complete set of indications for medicines. But actually, there are relationships that exist in the Odyssey vocabulary that make it possible for you to find those things. And if you have that, then it's actually possible to ask pretty slightly more advanced questions like, given that I've got a drug and I want to conduct some sort of comparative effectiveness study, well, that means I need to pick a comparator. What's an appropriate comparator? We could actually use the ontology to answer questions like, find me drugs that share the same indication, maybe that don't belong to the same class. And those are the types of hops we can take throughout the vocabulary to answer individual questions. Other types of questions we can ask in the condition domain. So during Phenotype February, we had lots of examples where we said, we read some sort of publication that described how they wanted to phenotype a particular outcome, and it listed a bunch of source codes, maybe like a set of ICD codes. The question is, how do you take that list of source codes and create a standard set of concepts that you might be interested in running so that you could actually run your analysis across any database around the Odyssey community? Or given a condition, can you go find related conditions? And so all of these are valid questions that regularly come up, at least in my research, and they are the kinds of things that once you get really facile with just querying the vocabulary, you can answer in a few lines of code. So very, very quickly before turning the floor to Christian, I'm just going to try to demonstrate how easy this can be. So somebody comes to me, not even a hypothetical example. Someone comes to me, well, just make sure that you're talking about all the TNF inhibitors. Tumor necrosis factor alpha inhibitors is a class of drugs that can be used for various indications. So how would I actually know that there exists a class of in the vocabulary that has something to do with that? I can write basically a 4-line SQL query to say select star from concept, check some of our vocabularies that are representations of different drug classifications, and I can just like look for the string tumor necrosis factor. And when I do that, I can see that there are concepts in the ATC vocabulary, in the ETC vocabulary, in NDFRT that contain tumor necrosis factor. But actually exploring the relationships in the ancestry from those concepts can allow me to say, well, tell me the ingredients that belong to that class. And here in 10 lines of code, one single SQL statement, I can actually return back that when a person tells me, make sure you get all the TNF inhibitors, I can get this list of 5 ingredients that represents those drugs in the class. And so now I can provide an actual mapping between that idea that was asked of me and what I actually need to go look for in the data. Another simple example of doing the exact same thing. Here, all I've done is I've switched out tumor necrosis factors, and someone said, just make sure we cover drugs that are used for diabetes. Turns out that in ATC, there's actually a class, drugs used for diabetes. And it turns out that there are 77 distinct ingredients of products that belong to this class. All of them are legitimate diabetic treatments. And yet there are different drugs used for diabetes in different geographies. If you read any clinical guideline, you go Google any page about diabetes treatment, you will not find all 77 of these drugs. The only way that you're going to find it is if you have a comprehensive knowledge base like what we have within the OHDSI vocabularies. Simple example, someone says, well, I've got a drug, can you go find me the indications? Well, it's easy to go find a drug concept. Here I'm typing the word adalimumab, which happens to be one of those TNF inhibitors. And I can go find that in 3 lines of code. But actually, we can exploit the vocabulary relationships to basically hop from the ingredient to its clinical drug up to its indication to learn from the ontology what are the indications of this drug. And we can see that adalimumab has indications for ankylosing spondylitis, Crohn's, psoriasis, RA, ulcerative colitis, etc. With a handful of lines of SQL, I can actually go find these relationships and learn about the drug without necessarily having to go pull out a medical textbook or trying to Google and hope that I get a complete list of indications. And given that I've now just said that I can hop from an ingredient to a clinical drug to an indication, well, I can also hop back to a clinical drug and to an ingredient, which means I can actually say, if I want to start with adalimumab, what are the comparator drugs for each of those indications? And what's exciting about that is that you can actually learn that for a given drug, if you want to do a study for a given indication, there may be different sets of drugs that are similarly approved for similar indications. And the vocabulary can actually help you find these things. Well, why is that relevant? It's all too often the case that I experience that somebody basically asserts that there is some study that they want to do, and they believe that they know what the appropriate comparator is. But actually, if we can let the existing knowledge base speak and let our data do the talking, we can actually empirically derive appropriate comparisons that might be more relevant and more appropriate questions to be asking. And these are the types of analytic tools that it really only takes here. You know, you can see it's only a dozen lines of code to be able to do a pretty complex operation that in the absence of the vocabulary would be nearly impossible to do in a consistent reproducible basis. So in the interest of time, I'm going to skip over some of these other examples. I'll just say that there are super simple queries that can do really powerful things that are available. But my takeaway point that I really want to share with you is I want you all to be thinking when you hear about the OHDSI vocabularies, don't just think it's a tool for ETL. Be thinking about how can you use it as actually an analytic device to enable you to generate reliable evidence. And so now that Mick's kind of walked you through exactly how the vocabulary works, and hopefully I've motivated some of you to realize that this is actually kind of cool. Let's have Christian, as Mick said, the godfather of the vocabulary, give us his own reflections on where we're at and where we need to go.
Thanks, Patrick. That was a very nice little showcase of how it works and what it does behind the scenes, but you can also use it directly. All right, so I wanted to do a little bit of a reflection, self-critique of where we are. It looks like precise science, but it actually isn't. But let's just go into it. We don't have that much time. So I want to talk what I think, maybe we collectively think, but really from my perspective at this moment, about how we are doing on the content, how we're doing on the service, vocabulary as a service, and the technology that we provide that people can utilize it with. So real quick, so you guys are a analytical crowd. So reading a complicated heat map is no problem. You see this thing and immediately have it fully passed through and got all the content in. So here's what I did. These are all concepts by domain, sorted by size. So drugs are by far the most, by order of magnitude, the largest domain with the most concepts. And then each, as you know, concepts can be standard, class, classification, or source. So you can see that there are about twice as many source concepts as there are standard concepts, and a little bit of classification. You'd expect that distribution for a healthy vocabulary. Okay. There are all sorts of different vocabularies from the different countries, even within the same country. And only some of them are standard, which are the ones which we use. Okay. So now if you go through, so I'm just going to go through drug and then very quickly through the rest. Essentially what this means is, next slide, fitness is how well does it work? Do the vocabularies work for our use cases? Can we capture drug? Does it work? Do we get into trouble? I'd say most of the time it works fairly well. Okay, so it's an almost full green. Completeness, do we have all drugs? I think with the exception of traditional or Chinese medicine type of drugs, the modern medicine type drugs, we should be in a very good shape. We very rarely run out of problems. Hierarchy, do we have a complete, well thought through hierarchy that we can rely on? I think we do. Duplication, do we have the same drug twice in there, both standard concepts, which shouldn't be. Don't think that happens very often. We may have like in the order of single-digit ones of those problems. And the mapping, how reliably can we map from source to standard? It's pretty well organized. So overall, I would give the drug domain a green, almost full green. Let's take the next one, which is device. Oops, no, yeah, exactly, thank you. That's the opposite, okay? We have no idea. The devices essentially are a big landfill. Any vocabulary that has devices contributes. We don't do much at all. We don't know whether we're complete. There's no hierarchy, zero. There is certainly a lot of duplication, not a duplication, triplication, quadruplication, a lot of, I don't know how many glucose sticks and pregnancy tests are in there all over the place again and again. And of course, no mapping. So this is a full red. Reason it's red is because probably the use case is less in demand, but that could be because we can't actually fulfill the use case very well. So it could be a chicken and egg problem. So if you look the overall, some of them are green, some of them are red. We really need to take care of the procedures and observations, in my opinion, because they are very much needed for the use cases that we do today. But generally, we should be honest about ourselves and also publish this much better so people know where we are, particularly if they do, when they do cohorts or phenotypes, because then you have to know whether or not you are deduplicated or whether you have to do lengthy concept chasing to make sure that you have all versions of a bone marrow biopsy in your phenotype definition or not. And that can be a lot because there are lots of different countries and it's getting more and more. So that's the content. So there's a lot to do. Now the service. So by service we have urgency, how much is it needed, and that we can respond to requests or needs. The next one is automation. How much do we have this stuff under control? So Nick showed you the machinery. How well does it work for all the vocabularies? How much is the crowd, our community, involved? Not a lot of green. Maybe with the exception of units and race, where there's a lot of crowd-based conversation going on. Documentation, Mick showed you, it's in the work. It's certainly not there. Some of them better, some of them worse. And support, and by support, I mean, you know, is there something, what do you do if you have a question, if you have a need? Is this clear, and is it well resourced? A lot of yellow and red. We are behind, we have a long backlog list. A lot of the people saying, hey, why don't we do this? We're gonna have to say, yeah, why don't you do it and make a proposal, okay? Work needs to be done. I think, you know, this can all be doable and it's cool. And I think the community is ready. We need to do something, okay? Technology is essentially from the perspective of the user, you guys, not the team technology. So release management, is there something where I can essentially check in and it's going to tell me exactly what I need to know for each release, and do I have to refresh my vocabularies or not, and which of them am I on, and what does it have, what does it not have? This is not automated at all. It's a lot of web pages and arm waving. Build process, it's okay. You can download, up and refresh, pretty much works. Could be done better, but it's greenish. The rest are orange, you know, documentation, dashboard, which is where are we, what's happening, where's my need, is it being taken care of? A cookbook. We need to have a cookbook so people can actually get involved very quickly and don't have to know whom to ask and who Christian is and who Mick is and who Dima is and so on. And access automation. Right now, you can't actually automate the whole thing fully. There's a lot of manual steps and we need to fix this. So I think I'm maybe a little self-critical, but it is, I intended it to be in contrast to Patrick's enthusiasm for the principal idea and that it can work. I think there's a lot of work to do that we have in front of us. We do have by far, from our use case, the best resource there is worldwide. There's no question about it. But in order to make it work better for the community to deliver on our mission, I think there's lots of work to do. That's 12 o'clock, 1800 in Europe.
Thank you, Christian. We really wanted to make sure to tee up, make sure everybody had exposure to what goes into the vocabulary, how you can use it, and where we're at. This is not the end of the discussion about the vocabulary, but we actually hope it will be the beginning. As Mick shared with you, there are places where you can actually start having conversations on the forum. If you've got issues with the vocabulary, you can literally log the issues in GitHub. You can take a look at the roadmap, but we really want to make sure that this really kind of hopefully is a catalyst for getting all of you who are interested to actually meaningfully engage in this community effort. I don't think our community can actually go on without this vocabulary, but I don't think everybody has as much visibility into what it takes. And I think that there's good opportunities for people to make meaningful contributions to keep our community moving along in this space. So I want to thank everybody for their attention today and look forward to continuing the dialogue about how we continue to advance this community resource for everybody's benefit.
Great. Well, thank you to Mick, Patrick, and Christian for leading this. I'm sorry we don't have time for Q&A, but of course you can still kind of put questions in the chat, or I would suggest on the forums if you have questions specifically about the vocabulary. The forums are a great place because there are probably other people who have similar questions. Thank you again to everybody who joined today. Please remember next week the session on reproducibility we will have, so that we're looking forward to that. And then again, Odyssey 2022 registration is open. Find out all of the information on the Odyssey website. Thanks everybody, and have a great day and a great week.